going. Divisibility test of 6 is therefore, as we have seen, 2 and 3, or we can say both. We can say both 2 and 3 must be able to divide that number. Let's go to another divisibility test. We are going to skip 7 because 7 does not have anything special with it. We are going to go to the divisibility test of 8. We skip 7 and we go to the divisibility test of 8. In the divisibility test of 8, divisibility test of 8, here we say that the numbers last 3 digits. The numbers last 3 digits must be divisible by 8. So if the last 3 digits are divisible by 8, then that number is divisible by 8. Divisibility test of 9. Divisibility test of 9. Divisibility test of 9. Test of 9. For a number to be divisible by 9, then the sum of digits, must be divisible by, the sum of digits must be divisible by 9. Let's go to the divisibility test of 10. Divisibility test of 10. In the divisibility test of 10, then if a number is divisible by 10, the number is divisible by 10. Number divisible by 10 if last digit is 0. Last digit is 0. And finally, we look at the divisibility test of 11. The divisibility test of 11. The divisibility test of 11. Divisibility test of 11. Divisibility test of 11. So a number is divisible by 11. A number is divisible by 11. Number divisible by 11. Divisible by 11 if the sum of digits, if the sum of digits in the first, third, fifth, etc. odd places is subtracted from the sum of digits in the second, fourth, sixth, or we say even places, if the sum of those digits are subtracted, then the difference is 0. The difference is 0 or 11 or multiples of 11 or multiples of 11. So that is the divisibility test of 11, and with that we have completed the divisibility test of numbers. You want to look at something else as we continue with the properties of natural numbers. We want to look at something else called GCD. GCD. We want to look at GCD. GCD, or we can also call it, which is the greatest common divisor of a set of numbers, a set of two or more numbers. So if we have a set of two or more numbers, for instance, if we have 12, e.g., factors of 12, that means factors which are basically numbers which can divide 12, or we can also call them divisors. Factors are also divisors. So factors or divisors of 12, or rather of 12 and 16. If you look at these two numbers, factors of 12 are 1, you can multiply, then 2 can also divide, 3 can divide 12, and 4 can divide 12, and 6 can divide 12, and also 12 can divide itself. So we have all those are the factors of 12. If we take the factors of 16, factors of 16, we can say are 1 can divide 16, 2 can also divide 16, 3 cannot, 4 can divide 16, and of course from there 8 can divide 16, and finally 16 can divide 16. So if we look at the common factors there, the one that is common to both and is great is 4. So 4, if you have this set of numbers, 4 is the greatest common divisor. So for these two numbers, so for both numbers, so for 16, 12 and 16, then we can say that 4, the GCD is 4. The GCD, or the greatest common divisor, GCD is 4. We also call it the highest common factor. GCD is also called HCF, or greatest common factor, and GCF. That is correct. So how do we find it? So the general rule for finding GCD, the rule for finding GCD is product of only the common prime factors. So if you have got a set of two numbers, factors of a set of numbers. So we have a set of numbers the product of only the common factors gives us the GCD. Product of only the common factors of a set of numbers gives us the GCD. So let's do an example of that. Example of GCD. Example of GCD is an example of GCD. Example of GCD. Example of GCD. We want to have a look at an example of GCD. An example of GCD is, we can say that, for example, we have got three numbers, 72, 96, and 300. So we can be told find GCD of 72, 96, and 300. Again, we'll go back to the good old table. We draw it quickly. Time is not on our side. 72, 96, and 300. And here we get, we start by 2. We are looking for only the common factors, so if we divide by 2, this will be 36. We start with the lowest prime factor that can divide all 2 is 2, 36.